His mother woke him up, kid napping, the kid was napping.
He went and boy that lost his draft.
That was like the first
Oh
thing
my.
that told me too.
Tucker,
That was like-
he went and boy that lost his draft.
Okay, so guys, I did want to show you guys some of these with like this function notation. So just to remind you guys, function notation is f of x equals y. We talked about this last chapter. So we'll finish up with these last couple of examples here. Last few. So f of x equals y. There's two, basically, they have 2 points here without us telling us there's 2 points here. It's just that different notation. So f of negative 5 equals 9. What's the x value then? F of x equals y. Yeah, Justine? It's negative 5. It's f of x. So that means what's in parentheses is the x. What's the y going to be then? 9. The next one, f of 11 equals negative 39. So that's just the coordinate point then, 11, negative 39. So it's just another way to show coordinate points. Again, why they have a different notation, I don't know. I wasn't there when they came up with it. I'm just like the bearer of bad news that that's what the rule is. So then, are we able to find the equation of this line? Mm-hmm. We should be able to. So for this, we're going to do our slope. So negative 39 minus 9, some big numbers here. 11 minus negative 5. We get negative 48 over 16. Which is just a negative 3, right? Oh no, it's not a nice number.
Oh, wait, yeah.
You divided something else again? Yeah. When she divides, she just picks up new numbers to divide instead of the ones that are there. All right. So negative 3 is our slope. And then again, we have a point already. So then we can take that point and take that m and put them together to find our equation. So y equals mx plus b. I know y is 9. M is negative 3. X is negative 5. Sorry, if you need to slide back that, or do a different scene. I know off the side it might be a little. So we're going to move this 15 over, and then we find our b. So b is actually negative 6. So m and b. So I don't think we have to do the whole other example like this, because you get the idea, right? So for this next one, just to make sure it's clear, it'd be a negative 4, negative 8, and then negative 8, negative 11. It's just that different notation. We don't have to go through the whole slope, but just knowing that's what's going on there. So the next question I want to talk to you guys about is kind of how this might apply in like real life situation. You hear about people talking about like business models, like how they calculate what they can make by selling something or having some sort of service. And that's kind of the situation we have here, where you want to figure out like what the rule is for our situation. So just know that obviously this isn't exactly like a real life situation, but it's trying to get you that idea. So we have a racetrack that charges membership fee and an entry per race. So So let's say you pay for something and you don't really pay attention to what the rate is, and you're trying to kind of figure that out after the fact. So a racer paid a total of $76 after 3 races. Another racer paid $124 after 7 races. We want to figure out what the membership fee is, so what's the flat rate, and then how much they get the cost per races, and kind of understanding that this equation kind of gives us all this information. Now, if you guys recall, when we talk about an x and y for a graph, which one did we say we can pick? Do we pick the x or the y when we made a table of values? We picked the x, right? So we decided the x values for our table of values. What can the race car driver, the racer, decide? Can you decide how much he's going to pay or how many times he's going to race? He gets to choose how many times he races. He can choose not to race at all. He can choose to race a bunch of times. So I'm going to write the race is actually my x value. And then the cost is going to be my y. Because he determines the number of races he does. The track determines how much he gets charged. So that's my x versus my y. So we're going to write these as coordinate points. Is that a sneeze? Bless you. I think. All right, so what's our first coordinate point? 3, 76. So when one racer races 3 times, it's $76. The other racer is 7, 124. And my questions are probably a little bit on the backward side here, because we're probably actually going to find the equation first and then determine like what our cost per race is and the membership cost. So we're going to figure out the slope. And it might not occur to you to figure out the slope because you're like, wait, we're not graphing like this line with the racetrack, but really we are finding a rate. We're finding how much it costs to race. So slope is something other than just graphing. So we get 48 over 4. So my slope is 12, and we'll talk about what that means in a second here. So our slope is 12. I'm going to kind of keep working my way through this to find my b, and we'll talk about what each of them mean. I'm going to use this one as my x and y. This 36 over. So if I know b is 40, so I'm going to write my equation. Right now, this equation probably doesn't mean much to you. But if you think about this situation and what's going on here, hopefully it'll make some more sense. That we've actually figured out, how much it costs per race, and we figured out what the membership cost is. Because what if he doesn't race at all, using this equation? What if he doesn't race at all? He's going to pay $40. What is that then? That's the membership. Just like if you get a gym membership and you don't go to the gym at all, I think this is like half the United States. If you get a gym membership but never go, you still pay that gym membership. So if he doesn't race at all, he still has to pay that $40. So the membership rate is $40. So what does the 12 stand for? How much he charges per race. So every time he goes to race, he gets charged $12. Once he's in with the membership cost, like obviously that's that flat rate, but then it's $12 per race. So this slope-intercept form has more of an application than just graphing lines, because a lot of times people are like, when am I ever going to use this in my everyday life? And I understand that you might not be trying to figure out the cost of working or racing at a track either, but that idea is there. Okay, so there are a couple questions like this at the end of the homework. Do not be afraid of them. Set up your points. You should hopefully be able to do that. All right, questions at all? The rest of the time to get working. Yeah. I will be sending you guys an email if I need to meet with you tomorrow at all for virtual learning. I'm actually going to be in person, so if you are here as well, you're always welcome to come work with me. Otherwise, I will still call you from here.